Welcome leaders, developers, and everyone on the front lines. We need to talk about what is, without a doubt, the single greatest infrastructure challenge of our generation, securing North America's energy future. Right now, we are in the middle of a massive shift. The absolutely insatiable energy demands of AI, of data centers, of reindustrialization, they're all crashing head-on into an electric grid that was designed for a totally different world. This isn't just a technical problem about keeping the lights on. No, this is about our economic competitiveness, our national security, and our very ability to innovate. The race is on, folks, and the stakes could not be higher.
So here's how we're going to break it all down in this explainer. First, we'll get a handle on the real scale of the crisis, what we're calling the coming power crunch. Then, we're going to get under the hood and diagnose the deep vulnerabilities of our current centralized system. After that, we'll explore the much better, much more resilient alternative, decentralization. And finally, and this is the important part, we'll give you a concrete blueprint for action, a toolkit for you, the leaders who are actually going to build the grid of tomorrow.
All right, let's dive right in. For almost 20 years, electricity demand in the US was basically flat. It was predictable. Utilities could plan years, even decades in advance with amazing accuracy. Well, that era is over. It's done. We are now staring down the barrel of an unprecedented surge in electricity demand that is pushing our grid to its absolute limit, and it is all happening way faster than anyone saw coming.
Now, this quote from Stanford researchers, it perfectly captures this bizarre paradox that we're dealing with. Our grid is simultaneously overwhelmed and, get this, massively underutilized. Just think about that for a second. We build this incredibly expensive system to handle peak demand, which might only happen for 100 hours a year on the hottest summer afternoons. The rest of the time, a huge chunk of that capacity, maybe 2/3 of it, is just sitting there, completely idle. So the problem isn't just about a lack of power. It's a profound lack of intelligence in how we manage the power we already have. And on top of that inefficient system, a perfect storm of new demand is brewing. You can see it right here. Over the next 5 years, the biggest driver is actually industrial and manufacturing reshoring, which is a huge policy win, don't get me wrong, but it comes with enormous power needs. Then you've got the electrification of everything, EVs, heat pumps, that's a quarter of the new demand right there. And then, of course, the real game changer, data centers and artificial intelligence. That slice is growing at a truly exponential rate. Let's really drill down on that AI number, though. 465 terawatt hours. That is the new demand expected from data centers just in the next 5 years. And frankly, that number is probably already out of date. Some projections put it over 1,000 terawatt hours by 2026. To put that in perspective, that is more electricity than entire nations like Japan or Germany use in a year. We're not just adding a new subdivision to the grid. We are literally plugging in a brand new power-hungry country. And here's where it gets really serious. This is not some far-off hypothetical problem. The North American Electric Reliability Corporation, NERC, these are the folks whose entire job is to keep the grid stable. They are flashing red warning lights right now. Their latest 10-year assessment is chilling. Over half the continent, including our biggest economic hubs, is now at high risk of blackouts during extreme weather. The safety buffer we used to have, it's gone.
Okay, so you have this massive new wave of demand. And what's it crashing into? It's crashing into an electrical grid designed for the 1970s. We're trying to run this incredibly complex 21st century digital economy on what is essentially an analog era machine. And you can see the cracks starting to form everywhere.
So the big question is, why? Why is the single most critical piece of infrastructure we have so fragile? Well, the answer really lies in this toxic cocktail of its age, its fundamental design, and the fact that it's just completely mismatched for the world we live in today. First, let's talk about age. We are running a high-speed digital world on infrastructure that is way past its expiration date. 70% of our high-voltage transmission lines are over 25 years old. That's more than halfway through their expected 50-year lifespan. More than half of our giant power transformers, the absolute workhorses of the grid, are over 33 years old. We're not just talking about needing a little maintenance here. We're talking about core components being at constant risk of failure, with replacement parts sometimes taking years to get because of supply chain issues. And we don't have to imagine what failure looks like. We're seeing it happen. The last few years have shown a really disturbing pattern. In 2021, Texas came within 4 minutes and 37 seconds of a complete statewide blackout that could have lasted for months. Just this year, a single equipment failure in Northern Virginia, the data center capital of the world, took 60 data centers offline. That was a terrifyingly close call for our digital economy. We're also seeing it globally, with huge blackouts in Spain and Portugal and repeated total grid collapses in places like Nigeria.
These are not isolated flukes. They are symptoms of a deep, systemic fragility. And that fragility is literally built into the grid's DNA. Engineers have a term for it, a single point of failure, or SPOF. Our grid is a classic centralized hub-and-spoke model. You have a few huge power plants pushing electricity out through massive transmission lines to everyone else. The problem is, if you take out one of those critical hubs, a big power station, a key transmission line, a control center, the whole network can go down like a line of dominoes. It is an inherently brittle design. See, the grid we have was designed for the world of the 1970s. It was predictable, power flowed one way, from the plant to the people. Simple. But today's grid is a totally different beast. We have renewables like wind and solar that are unpredictable. We have distributed energy sources like rooftop solar panels and EV chargers in people's garages that can actually push power back onto the grid. All of this creates a chaotic, two-way flow of energy that our old analog system was just never, ever built to handle. Okay, so we've spent a lot of time diagnosing the problem. Now let's talk about the solution. And it's a big one. We have to move away from this brittle, centralized model and embrace a whole new way of thinking. A decentralized, resilient, and intelligent grid that's actually built for the 21st century. The best analogy I can think of for this shift is the internet itself. Remember the old landline phone system? It was centralized. If a major switch failed, a whole city could lose service. The internet, on the other hand, was designed from day one to be a distributed, fault-tolerant network. If one connection goes down, data just instantly finds another route. That is exactly how we need to start thinking about our energy infrastructure, not as one giant fragile machine, but as a robust network of thousands of interconnected, intelligent, and semi-independent nodes. And this chart? Wow, this really lays out the night and day difference between the old model and the new one. Look at the utilization rate. We go from a wildly inefficient 30% to a potential 90% with smart, dynamic orchestration. And for you developers listening, check out the interconnection time. The current 4 to 12-year wait to connect to the grid, that can become a matter of months with plug-and-play microgrids. And most importantly, look at the resilience model. We shift from that fragile hub-and-spoke system to a fault-tolerant mesh network, where the worst-case scenario isn't a regional blackout, but just localized downtime. And this isn't just theory. This is what advanced resilience modeling shows us. This chart uses a sophisticated model to map how a failure in one part of the system cascades and affects everything else. And the results are just undeniable. In a centralized grid, one major fault causes a high level of disruption across the entire system. But as you start to decentralize, even partially, the impact of that exact same fault drops off a cliff. A fully decentralized system is just inherently tougher. It contains problems locally, stopping them from spreading and taking down the whole show. Okay. We've just walked through the core principles of what makes a grid truly resilient. This kind of deep dive analysis is exactly what we're all about here at Digi-Gold. So if this is proving valuable for your work, for your planning, for your policymaking, please take a quick moment to hit that subscribe button and share this explainer with your colleagues. Your engagement really helps us create more content to empower leaders just like you. All right, now let's turn these ideas into a practical plan. Okay. Let's get practical. Let's translate all these concepts into a real-world blueprint. This next section is all about the actionable toolkit for you, the leaders and the developers who are actually out there on the front lines building our energy future.
Now, believe it or not, the single biggest lever we can pull has nothing to do with fancy new technology. It's all about cutting through bureaucracy. I'm talking about comprehensive permitting reform. Right now, it can take over a decade just to get the permits for a new transmission line. That's insane. We can slash that timeline to just a few years by making the process predictable and transparent, by forcing all the different government agencies to coordinate before a project even starts, and by identifying critical energy corridors where we can fast-track approvals.
This right here is a golden rule. It's absolutely crucial. Before we even think about building massive new power plants, we have to get smarter about optimizing the huge underused system we already have. That means using AI for better grid management, predicting demand, and dispatching resources in real time. And it means empowering businesses and consumers with behind-the-meter solutions so they can reduce their own reliance on the grid. One of the most exciting policy tools for this is a model called Consumer Regulated Electricity, or CRE. Think of it like an express lane for new, power-hungry industries. Let's say a new data center campus wants to build, but the local utility says it's a 7-year wait for a grid upgrade. Well, CRE allows that campus to partner directly with a private energy developer to build its own dedicated microgrid.
We're seeing this happen in places like Ohio and West Virginia. It's a total game changer. They get reliable power in a fraction of the time, and this part is key, it doesn't force existing residential customers to pay for their massive infrastructure needs.
For all the developers and large property owners watching, this slide is your playbook. You can't just assume the grid will be there for you anymore. You have to be part of the solution. First, on-site battery storage. It's not just for backup power now, you can actually sell services back to the grid and create a new revenue stream. Second, behind-the-meter generation, like rooftop solar on your warehouse. It cuts your costs and reduces strain on the grid. Third, for big projects, build true microgrids that can island themselves and run independently during an outage. Fourth, go after the public-private partnerships and financial incentives out there. There are a ton of them. And finally, work with your local utility. They're desperate for solutions, and your project could be exactly what they need.
So let's bring it all home. What does all of this actually mean for you, for your companies, and for the communities you serve? We've defined the problem. We've outlined the solutions. Now it comes down to leadership. It comes down to making a choice. You are standing at a crossroads, and the choice you make right now is going to directly shape your community's economic future for decades. Path 1 is inaction. It means more strain, more blackouts, economic pain, and watching as those big investments, those new data centers, go somewhere else that has reliable power. Path 2 is proactive leadership. It means fighting for policy reform, building those public-private partnerships, and creating a modern, resilient grid that becomes your community's competitive advantage, something that attracts investment and guarantees prosperity. And I want to be clear, this is not an exaggeration. As Dr. Sarah Kapnick from JP Morgan puts it, this isn't just an infrastructure issue anymore. This is a fundamental pillar of our economic development, our industry competitiveness, and yes, our national security. The simple truth is, the communities that solve this power puzzle first are going to be the economic winners of the 21st century.
We designed this explainer to be a tool for you. Please share it. Use it to start these crucial conversations with the stakeholders in your city, your county, your company. Your voice is essential in this debate. And of course, if you haven't yet, please do take a second to subscribe to Digi-Gold for more deep dives into the critical issues that are shaping all of our futures. When we work together on this, we can make sure this transition to a modern energy system is a massive success.
So we'll leave you with this one final thought. The technology to fix this, it exists. The business case, it's crystal clear. The blueprint for a resilient, decentralized future is right here on the table. The only thing missing, the only variable left, is leadership. The 20th century grid has hit its limit. The real question is, what are you going to build for the 21st?